Welcome to Chapter 5, Fats. Remember to read your chapter thoroughly. The videos are supplementary to the chapters and highlight the key points of the chapter. The videos are broken down for each chapter into smaller units. This will make it easier for you to download them and easier if you'd like to go back and review a certain portion of the chapter. Sometimes we'll be spending a little bit more time on one slide than another, but be sure to know that you are responsible for all of the material. So please make sure you review all of the slides that are provided for you in these PowerPoint presentations. Now let's start talking about fats. What are they? Fats are one type of lipid. The general umbrella term of lipid actually includes both fats and oils. Fats tend to be solid. Oils tend to be liquid, and we'll get into some more details of those in a little while. Lipids are a diverse class of molecules that are insoluble in water. Lipids do not dissolve in water. And a good visual of this would be very simple for you, that if you took a piece of butter or a pat of butter, and if you put it in a cup of water, it would not mix well. They would stay completely separated from one another. Or even if you dumped some oil in a cup of water, you would see that the oil remains separated from the water, and that's because they will not dissolve. The oil will not dissolve in the water. Now, there are three types of lipids that we find in foods. We have triglyceride, and that's the most abundant type of lipid that we find in the human diet, but we also have phospholipids and sterols in smaller quantities. Now, triglycerides are composed of three fatty acid molecules that are long chains of carbon atoms surrounded by hydrogens. And these long chains of carbon atoms surrounded by hydrogens are actually bound to what we call a glycerol backbone or a glycerol molecule. So a triglyceride means that there are three fatty acids that are joined together, held together by a glycerol backbone. So what is a fatty acid? Well, a fatty acid is what we call kind of the simplest unit of a lipid in our diet. So the fatty acid is kind of the simplest unit, and again, when we join those together and hold them together with glycerol, it's called a triglyceride. In this diagram, you'll see an example of the triglyceride, and this blue over here represents the glycerol backbone, and then these wavy lines represent the three fatty acid molecules that are joined together. And again, notice the atoms that make up a triglyceride. They're carbons, hydrogens, and oxygens. Now, fatty acids can differ in the length of their carbon chain. We have what we call short chain fatty acids, and those are less than 6 carbons. Medium chain fatty acids are 6 to 12 carbons in length, and long chain fatty acids are greater than 13 carbon molecules in length. The most common fatty acids that we find in the human diet are long chain fatty acids. Now, we also have different levels of saturation, and saturation refers to how many hydrogen atoms surround each carbon. Every carbon atom can bond 4 things or up to 4 hydrogen atoms. The shape also differs from fatty acid to fatty acid. Now let's get into this in a little bit more detail. Generally, fatty acids or saturated fatty acids have hydrogen atoms surrounding every single carbon in the chain. So in other words, they have no double bonds. Anytime you see a double bond between carbon atoms, it means that there's room for it to hold more. So again, saturated means that it's basically the carbons are full and they cannot hold any more hydrogens. Now, monounsaturated fatty acids means that there's a lack of hydrogen atoms in one region, that there's one double bond in the entire fatty acid. Examples in the diet of monounsaturated fatty acids are olive oil and cashews. Now, polyunsaturated fatty acids, on the other hand, lack hydrogen atoms in multiple locations along the fatty acid. In other words, there are 2 or more double bonds when you look at that fatty acid molecule. An example of a polyunsaturated is corn oil. In this picture here, you'll see an example again of the fatty acids. If you look at the top one where it shows a saturated fatty acid, you will see where the carbons are located, there's a single bond throughout the molecule. Now, if we move down to our monounsaturated, you will see that there's one double bond in the middle of the fatty acid. And if we move to our polyunsaturated fatty acids, you will see that there are, in this case, two double bonds within that fatty acid molecule, hence the word polyunsaturated. Now, the shape of a triglyceride is determined by the saturation of the carbon chains. Saturated fatty acids can pack tightly together and are solid at room temperature. Examples of saturated fatty acids include coconut oil, animal fats, butter, and lard. Unsaturated fatty acids, however, do not stack well together and are liquid at room temperature. The unsaturated fatty acids are the predominant type in plants. The two exceptions to this are coconut and palm kernel oils. Even though those are oils, they tend to be saturated. Now, the hydrogen atoms at the unsaturated region can be arranged in different positions. We have what we call cis and trans. In a cis fatty acid, it means that the hydrogens are on the same side of the carbon chain. A trans fatty acid means that the hydrogen atoms are on opposite sides of the chain. This is an example illustrating that stacking feature that we talked about. If you see here, the saturated fatty acids tend to stack nicely together, and as a result, these are solid at room temperature. On the other hand, the unsaturated fatty acids do not stack, and as a result of them not stacking, they remain liquid at room temperature. Here's an example showing you the cis versus the trans arrangement here. Again, in the cis fatty acids, the hydrogen molecules are on the same side of the carbon chain. In a trans fatty acid arrangement, as you'll see here, the hydrogen molecules are on opposite sides of the carbon chain. Now, let's talk a little bit more about this whole concept of trans fatty acids because they get a lot of attention. Hydrogenation is the addition of hydrogen atoms to unsaturated fatty acids. Let me give you a simple example here. In the old days, it was very common for individuals to cook with animal fat or with lard. Lard is solid at room temperature. And when we cook with lard, if we make a cookie or a pie crust or use it for deep frying, it gives a nice texture and a nice flavor to our foods. However, we realize that using animal fat, there are some consequences health-wise. So food manufacturers over time, what they have decided to do is to create something that mimics lard in cooking. If we take an unsaturated fatty acid or a nice vegetable oil, and if we add hydrogen atoms to that oil, we can create this solid mass that resembles lard. And then when we cook with that lard, it gives foods a nice texture and a nice flavor. Now, a lot of you will know what this is. If you look at this in a supermarket, you can actually purchase this, and it's called shortening or vegetable shortening. It's where we've taken a nice plant oil and converted it to this solid mass. Now, when we're looking at food labels, how do we know if there's trans fatty acids? Well, fortunately, it is required by law on a food label, so the amount must be listed. And if it's a very small amount, then it must be listed in the ingredients as partially hydrogenated oils. Now, the problem with these trans fats is that they tend to play havoc with our blood lipids. We know that saturated fats tend to make our bad cholesterol go up, and we think trans fats are a double whammy in that it makes our bad cholesterol go up and our good cholesterol go down. So we want to eliminate trans fatty acids in the diet. And then on a final note about trans fatty acids, there is no DRI for trans fatty acids. In other words, they are not required in the human diet. Please proceed to the next video in the series.